Today we are going to continue our work with factoring numbers, our divisibility rules, but we're also going to add in there an entire list of factors, so just not the factors 1 through 10, and also finding perfect squares. So just review from yesterday, right? We always know that a number is divisible if it has a remainder of 0, which means when we divide it, there's no fractions, there's no decimals. We know that a number is always divisible by 1 and itself. And if a number divides another number with no remainder, right, we call that a divisor or a factor. So those numbers that we were finding yesterday, when we said, yes, it's divisible by 2, 2 is then a factor of that number. Okay, so today we're going to start making factor tables to list all the possible factors. Now, the approach we started with yesterday was, right, we tried 1, we tried 2, we tried 3, we tried 4. But as we get to bigger numbers, right, we don't want to be trying 55, 56, 57, 58. So if we put this in a table, we're able to find all the factors by doing half the amount of work. So we're going to start with the same idea we did yesterday. So we're going to find if 20 is divisible by something. Now, many of you yesterday were using a calculator, either a handheld calculator or your Desmos calculator, either is fine, right? And for example, we said to start with 1 and itself are always factors. Now, notice how I'm writing these on each side of the table. The reason why I'm doing that is because 1 times 20 gives me 20, right? So then we'll check and see if 20 is divisible by 2. Now, 20 is even. It ends in 0, 2, 4, 6, or 8, so we know it's divisible by 2. Worst case situation, right? We picked up our calculator and we said 20 divided by 2. Okay, so since that works, we're going to write down 2. Now, 2 times what gives me 20? You either can know that mental math or you can use the answer that comes out of your calculator. So the answer that we get is 10. So 2 times 10 is 20. Right? Then we would try 3. So our rule of 3 yesterday was we added 2 plus 0. 2 is not divisible by 3, so it wouldn't work. Or you can use your calculator and you can divide by 3. Right? 3 does not work, so we're not going to add that to our factor table. Right? Then we're going to try 4. So whether you're dividing that in your calculator or whether you're using our rules from yesterday, right? This is 4 times 5. You will continue this process until the next number that you write down here. So right, 1, 2, we tried 3, it didn't work, 4. The next number that we would write down is 5, but 5 is already on the other side of our list. So because 5 is already on the other side of our list, we know that our list is complete. So we would say that 20 has factors of all of these different numbers. So if we sort of go this way, right, that will give us numerical order 1, 2, 4, 5, 10, and 20. Okay, so we're going to practice that with a couple numbers here and see how we do. So how about the factors of 16, right? So if we want to list our factors of 16, we're going to start by writing down the number and making our table. We know our starting point is always 1 and itself, right? 1 times 16 is 16. Then we'll try 2. 2 is divisible, right? So 2 times 8. Now again, if you're not for sure, you can pick up your calculator and you can type in 16 divided by 2, which gives us 8. So 2 times 8. Then we'll try 3. 3 does not work. It gives us a decimal, so we're not going to put that on our list. Then we'll try 4. 4 times 4. Now, whenever we get to a point that we are writing down the same number, right? Our next number would be 5 in the list. You're like, oh, 5 isn't over there. But we already duplicated 4. That's another reason that tells us our list is done, right? I wrote down that number twice, so my list is done. So we would say 16 has factors of 1, 2, 4, 8, and 16. Okay, let's try 45. All right, we're going to make our table, and we'll start making our list, right? We're always going to start with 1 and itself. Then we'll try 2. 45 is not even. or you can check your calculator. So 2 does not work. All right, then we'll try 3, right? Whether you're picking up your calculator and you're typing in 45 divided by 3, or you know that 45 divided by 3 is 15. Right, we would try 4. 4 does not work. 45 ends in 5, so we know 5 works. So 45 divided by 5 is 9. All right, we try 6. Remember we said yesterday 6 is one that we would check 2 and 3. 2 doesn't work, so 6 won't work. We'll try 7. That gives us a decimal. We'll try 8. That gives us a decimal. 9 is already written down, so we know we have our entire list. So we'll say 1, 3, 5, 9, 15, and 45 are our factors. So let's do 36. Again, our starting point is always 1 in the numbers, so 1 and 36. 36 is even, so we know 2 will work. Again, whether you're picking up your calculator and you're typing in 36 divided by 2 gives us 18. Whatever works for you. 3 will work. Again, we can type in 36 divided by 3, which will give us 12. 4 will work. 36 divided by 4 is 9. 5 will not work. It does not end in 0 or 5. But 6 will work and we'll get 6 and 6, right? We duplicated a number here. So we know we're at the end of our list. So we would say it has factors of 1, 2, 3, 4, 6, 9, 12, 18, and 36. Last one we're going to check here is 42. Okay, so if we're checking our factor list, we'll start with 1 and 42. 42 is even, so we know we can do 2. 2 and 21. 3 will work. Again, you can pick up your calculator, right? I've said this every time, so you can do 42 divided by 3. Gives us 14. 4 will not work. 5 will not work. It does not end in a 0 or 5. 2 and 3 work, so 6 will work. Right, the next number that we would write down is 7, so we have our entire list. So 1, 2, 3, 6, 7, 14, 21, and 42 are all factors of 42. Now, the last thing that we want to note here is that when we look at a factor list, when we look at this table that we made, if we get to the end and we see a number times itself, we call that a perfect square. Okay, a perfect square is any time we can find a number times itself. So for example, 16 is a perfect square because it is 4 times 4. So if we look at the other examples we've done, we'll see a couple other perfect squares, right? Right here above, this was a 6 times 6, so 36 is a perfect square, right? 16 on that page 8, right, was 4 times 4, so 16 is a perfect square, right? Anything that is a number times itself. So 1 times 1 is 1, so 1 is a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, 16, 25, right? All of these numbers give us perfect squares. Now, there are more perfect squares than just this set that we listed out. So anytime you're making a factor table and you get to this number times itself, we should understand that that makes it a perfect square.